The other day, I went into the geochemistry lab and I found the Schlumberger logging engineer and the geochemist marine technician doing an experiment that involved soda cans. I asked them, what are they doing?
So basically the idea is we wanted to measure the resistivity of the drilling mud.
Right.
Because the downhole logs are affected by borehole fluid. So normally we have a little device for that. We don't happen to have one on board, so we improvised one.
Hold on. Let's first talk about what downhole logging is. Thanks to CM Offshore, who have actually drilled the seafloor to collect our core for the scientists to look at the core on the ship itself, we still have some data to collect in the borehole itself. We want to look at the structural and physical characteristics of the borehole so that we can correlate what we see in the borehole to what we see in the core. That will help us get a better picture of what's actually happening in the seafloor. One of those characteristics is looking at resistivity, and that is what Clay is talking about.
Resistance, electrical resistance, is just basically the resistance to voltage or current flowing through a wire, for example. So you can measure that with a meter. You take a multimeter, you attach one probe to each end, and you can measure the resistance. Electrical resistivity in oil field or in geology is basically the same thing, except you don't have the ability to attach the wires to both ends of the wire, or probes to both ends, so you have to measure from a single source. So what ends up happening is you have to normalize that data over volume in order to get an accurate measurement, or repeatable measurement. So the way that's defined is by a unit called an ohm meter rather than an ohm of resistance. So what that means is that if you were to make a 1 cubic meter box with electrodes on either side, 1 square meter each, 1 meter separation, and you were to measure 1 ohm of resistance between those 2 points, that would be the definition of 1 ohm meter. Okay, so what we're trying to do is find a way to convert ohms, which we can measure with any multimeter, into ohm meters, which you can't directly measure with a multimeter.
It might help for you to know that the downhole logging tool that measures resistivity in the borehole outputs only ohm meter results. That is why Clay needs to be able to convert between the ohms from his multimeter to the ohm meters so that he can then compare the results to each other at the end of this experiment.
So that's the bottom line. And the way we do that is we take a non-conductive container of some kind. In this case, I used a piece of core liner, so it's just this piece of scrap basically. We attach electrodes at either end, parallel to one another, and we fill the chamber with fluid with no air. So what I've done is I took basically just 1 soda can, put some RTV glue on there to seal it and isolate it from the shell. And the other end is essentially another soda can with the top cut out and 2 holes punched in it to allow the air to purge. So as we put the thing in here, we fill the fluid up to slightly higher than the level where this will stop. And I've got a piece of tape on here to make it stop at a distance of 10 centimeters. So fill the fluid in, 110, somewhere in there. We gradually let this guy press in. As it does, the fluid is squeezed into here along with the air, purged. And now we have a known length and a known diameter. So we now have all the geometry necessary to compute resistivity.
So now he has his contraption to help him get to resistivity. But to get started is when I found him in the geochemistry lab. He was measuring salinity levels. He was mixing up water with sodium chloride or just salt and was measuring the salinity levels of that water and taking that to compare to a conversion chart that helps you know what salinity levels equate to resistivity levels at different temperatures. That's how he can get to resistivity of drilling mud.
Well, when you do lateral log, the way a resistivity measurement works, the current actually passes from the tool through the borehole fluids and then through the fluids in the formation, and it returns back to the tool. So it makes kind of a loop, and it computes resistivity from that. The problem is if we don't know how resistive the fluid is in the borehole, we don't know what contribution that had to our measurement. So if we can characterize the mud, we can essentially account for that when it comes time to interpret the signal and say, well, this is salt water, or this is hydrocarbon, or this is some combination of the two, or whatever.
Now, whatever, Clay, you helped us ground truth the resistivity measurements so that the scientists can rest assured that their logging data is as accurate as possible. All thanks to a soda can experiment.